Okay, in this video, we're looking at factoring trinomials that have a leading coefficient other than 1. So in other words, look at example A. It has a leading coefficient of 2 here, and we can't factor it out because there's no greatest common factor in this trinomial, right? There's no way we can take a 2 out of this term, so that means we're stuck with the 2. We have to work with it. All right, now the thing that we want to notice here then is that essentially this trinomial is still going to be factored by using the two parenthesis approach that we used in the previous examples. However, we're going to have to deal with numbers both in the front and on the back end. So let's think about the factors of 2 here. So it'll be 1 and 2, and let's think about the factors of 36. Well, we'll have 1 and 36, we'll have 2 and 18, we'll have 3 and 12, we'll have 4 and 9, and then we have 6 and 6. Those are the factors of 36, so we have lots of options. All right, so you can see we have lots of options for the factors of 36. So I want to point out something, and that is we can't use this simple rule that we're looking for factors of 36 that subtract to give us 1, right? That's not what we're doing here. We can't do that because we have this 2 in front. The 2 in front is going to interfere with that sort of thinking. In other words, if we really wanted to do this, we could use something called the AC method. You might have seen people do this before. They'll say something like, hey, we're looking for factors of 2 times 36, or in other words, factors of 72 that subtract to give you 1. And you can do that. You can certainly do that and then piece together your middle term. I've done that before. It works great for someone like me. Whether it would work great for you or not is questionable. In my experience, it works best for students to just use trial and error with a little bit of rules to help them eliminate choices and to make wise decisions. So what I'm going to do here is just show the trial and error approach. So first thing we want to look at is the fact that 2 didn't break up to too many factors. It's prime, so we only have 1 and 2 as choices, right? So I'm going to do 2 and 1 just like that in the front. That splits up the 2 in the the front of the parenthesis where it belongs. And then we're going to take the x squared and break it up as x and x. So that part I think is very easy. No question about that. Now, we look at this sign here on the back end and we would say what? That sign indicates we have to have a sign of each inside the parentheses. So it means we're looking for a plus and a minus then in the parentheses. Does it have to be plus minus or could it be minus plus? We don't know. We're just going to have to use trial and error to figure that out. Now, for the 36, we're going to try one by one the pairs and check the middle term to see if it adds up to 1 like we want it to. Now, the 6s we would try first normally, right? And I say normally, right, because I think I mentioned in the previous video that we always try the closest pair first. So 6 and 6, it couldn't get any closer than that, right? The factors 1 and 36, for example, are the farthest apart. 6 and 6 are the closest together. So we would try 6 and 6 first. But here's the thing. We're not going to be allowed to put 6 in the parentheses here. The reason why 6 can't go in the parentheses is because we have two 6s, we have to do 6 and 6. We have no choice there. We have no choice but to put a 6 with the 2 here. And that's a problem, actually. The reason why it's a problem is you're not allowed to have a GCF in this binomial, right? The 2 and the 6 would have a greatest common factor, but that can't be because there was no greatest common factor in the original trinomial. If there are no greatest common factors in the original trinomial, you cannot have a greatest common factor in your binomial pairs. That would be impossible. So that means 6 and 6 cannot be the right answer because we have no choice but to put the 2 with the 6, and that would lead to a GCF, which we're not allowed to have because we didn't have a GCF in the original problem. So we're going to eliminate this 6 and 6 option. It doesn't even count. We can't use it. So that's actually really helpful then. All right, so then we could try 4 and 9, right? 4 and 9 is the next pair on the list that we should try. So we're going to try 4 and 9 next. Now 4 and 9, could I put the 4 here like this? Could I put the 4 in that parenthesis and then put the 9 here? Would that be okay? Well, the answer is a definite no-no again, because what? We just said this cannot have a greatest common factor. This binomial on the left here would have a greatest common factor if I put 4 there, so I'm not allowed to do that. So if I'm familiar with that rule, then I'll say, okay, I can't try the 4 there. That's not possible. So I'd have to try, if I'm going to try 4 and 9, I'd have to put the 9 there. The 9 can go there, and the 4 can go here. That's okay. And if I check that, what do I get? I get 9 times x, or 9x. And then if I get 2x times negative 4, I get negative 8x. And sure enough, if I subtract these two, 9x minus 8x, I do indeed get 1x, the middle term. So the middle term is there. I'm good. This is the correct factoring then. And even though it's trial and error, I pretty much eliminated the first option we had, and I settled on the second option, and that second option worked. So basically in one guess, I was able to get the answer right. All right, let's continue then with example B. So with example B, I would check first to see if there's a greatest common factor. I can see that this 3 has nothing in common with the other terms, and that's all that last term has is a 3. So I think that we cannot factor out a greatest common factor. So let's go ahead and try then to use the two parenthesis approach. I copy down my two parentheses to hold my binomials, and I have to think of factors of 8. Well, we have 1 and 8, and we have 2 and 4, and that's it for 8. We don't have any other factors. For 3, we're limited on factors 2. We just have 1 and 3. Whenever we have such a small amount of options, it's really helpful. So what I'm going to do is always start with the first one, the 2 and the 4. I always try those first. So I'll use, for example, 2x and 4x. Now from there, I'm going to be looking at the factors here of 3. We have 1 and 3, and I can pair these up however I want. So what I'm going to do is try to put, for example, say 3 and 1 like that into the parentheses and see what that does. So first thing I'll do is multiply the inside terms. I get 12x, and then I have 2x here. And if I go to subtract these, I will indeed get 10x. So that was literally just my first guess. I didn't mean for it to work out so perfectly on the first try, but it did. All I have to do now is watch out for the signs. Look at the back sign here. You can see that that sign in front of 3 is negative. It means we have to have a sign of each inside the parentheses. So with the fact that the signs have to be one of each, what if I put the plus here and the minus here? What would that do? Well, that would make this 12 a positive 12, and it would make the 2 negative, giving us a positive 10x as the answer. But is that what we want? Do we want a positive 10x? I don't think so. Our sign here is negative, so we're actually going to need to change the order of the signs around. Remember, this last sign being negative tells us we have to have a sign of each, right? One positive, one negative. So what I'm going to do is erase the positive and negative that I had here originally. I'm going to change the back one to positive and the front one to negative. Then what does that do? Well, we're going to be changing the signs here and here, because that would mean that negative 3 times 4 gives you a negative 12x, and positive 1 times positive 2x is going to give you a positive 2x, the difference there being negative 10x, and this is our middle term in the polynomial. So we're done at that point. Our factoring is complete. Okay, so let's begin example C now. So same thing as always, we'll look for a greatest common factor. 2 is prime and 5 is prime, so there's no greatest common factor between those two terms, and that means there's no greatest common factor throughout the trinomial. From there, we're going to look at factors of 5. Well, we have 1 and 5 as factors of 5, and for factors of 2, of course, we just have 1 and 2. This is great because we don't have many options. It would be easier to find the pair that works. So 2 parentheses and begin the trial and error process. So I'll do 5x and 1x here. And then because there is a positive sign here, that's useful because it tells us it's going to be 2 of the sign on the left there. That's going to be 2 positive signs. And then we're looking at factors of 2. Now I don't have many options here, so if this polynomial is going to be factorable, it really has to be something like 2 and 1 or 1 and 2. So let's try the 2 and 1 first. Well, 2 times 1 here is going to give you 2x, and if I do the 5 times 1, I will indeed get 5x. And if you add these two together, you do indeed get the middle term of 7x. So basically we're done. First guess, and we're correct. So again, trial and error really does work. It's really just a matter of using intelligent guessing, and from there, we get our solutions pretty quickly oftentimes. Okay, now we have our last example here, example D. Let's move up a little bit so we have some space to work out D here. So it looks like D has a greatest common factor. I can tell that because all the coefficients here, all the numbers here are even. And even numbers always have a 2 in common at the very least. I think that's all they have in common because, for example, 6 really is just 2 and 3, right? 2 times 3. There's no 3 in 16, so I'm pretty sure we'll only have 2's in common. So let's take a 2 out from everything and see what we get. If I pull out a 2, I'll have 3x squared minus 14x plus 8. So from there, what I need to do then is to go ahead and split it into 2 parentheses, being very careful to bring down my greatest common factor when I do that. You don't want to forget it up above. So I'll pull it down, put my 2 parentheses, and then I'm going to go ahead and try to split up my trinomial into 2 parentheses. Okay, so we'll try, for example, 3 and 1, x and x, and I'm doing that for the 3 there in front because we don't have options for 3. It's got to be 3 and 1. Now what's nice about the plus sign at the back end here, it means 2 of whatever sign here is in the middle. That's 2 negatives for us. And then we need 8, right? So we need to split up 8. Now 8 has a couple of factors. We can have 1 and 8, or we can have 2 times 4. And so I think we'll try the 2 and the 4 first. Remember, that's our traditional approach, to try the closest pair first. And from there, I can do, for example, 4 and 2 and see what that gives me. That'll give me negative 4x and then negative 6x. Well, if I combine those, I only get negative 10x. That's not what I'm looking for. I'm looking for negative 14x. So it's not going to work to do 4 and 2. However, if I simply make a change here, if I get rid of the 4 and 2 and switch it for 2 and 4 in that order, so I put the 2 here and the 4 here, things will work out a little better. Minus 2 times 1 is going to give you negative 2x, and then minus 4 times 3 is negative 12x, and now you can see negative 12 and negative 2 do indeed give you the negative 14x we have in the middle. So 2 and 4 are going to work in that order, and that means that our factoring is given by this solution here.